Okay, guys, this is Miss Jones. You guys are going to be taking notes, so you should have taped this page into your notebook, and let's get started. We are focusing on understanding some new terms that we're adding to our chemistry unit. We're understanding atoms, elements, compounds, and mixtures. Now, we've already briefly kind of talked about atoms, so we're just going to delve into that a little bit more. As we're going through this, you guys should be looking at your notes and following along. Our essential question today is basically, how do you determine the number of atoms of an element that are present in a chemical formula? So we're going to take formulas like one you guys really know very well is H2O. We're going to take formulas like that, and we are going to be able to count how many different elements are inside of it, or how many different atoms of each element it is that we have. So let's start with this first slide that you see here. Your first question or main idea on the left should be, what is an atom? Well, let's fill in the definition. An atom is the basic component of all matter. That's something we've already, kind of talked about. So in that first blank, the word is bolded and underlined, so you should fill that in. It's the basic component of all matter. And look, there's a picture of an atom right here on the screen. Here's another picture of an atom that you guys have seen before. Here's a different one. These are all atoms. And as we know, an atom consists of 3 subatomic particles. You have the positive, which is your proton, the neutral, which is your neutron. Both of those go inside the nucleus, which is this area right here. And then we have our electrons, which are here on the outside in the electron cloud. Our second essential question is, what is an element? This is also something that we've kind of already discussed, but let's just make sure we have the proper definition. It is a substance consisting of a single type of atom, and it cannot be broken down into different kinds of matter. So if you look here on this graphic, we have an atom of helium. You cannot break down this atom of helium and turn it into an atom of hydrogen or add to it or anything. You cannot break this down. An atom of helium will always be an atom of helium. And since it is an atom of helium, altogether it makes one element or a specific element, which is helium. Okay, let's look at our third question or main idea. We are now defining mixtures. This is something you've probably talked about as early as you can remember in science in elementary school. It is a substance consisting of 2 or more substances mixed together. And don't forget, you should be filling in these words as you go along. And there are many different examples of mixtures that I'll show you here in a second. But basically, a mixture can be separated. It can be separated, okay? It's 2 or more substances mixed together in such a way that each individual component that is added to the mixture can be separated and still maintain its identity. It's kind of like you have a mixture of friends, okay? But all of you don't also share the same type of friends outside of y'all's own individual friendship. So if Mary, Susie, and Bob are all friends together, they're a mixture of friends. But then Bob has another mixture of friends named Carol, Susan, and Ricky, then that's a different mixture. He still gets to maintain who he is in his original group and his new group. So here's another mixture, a salad. Actually, that's the same one from the previous picture. Water and oil are mixtures. Don't believe me? Pour some water in a cup, put some oil in it. They will not blend together. Soil is a mixture. Think about the kinds of things that you find inside of soil. You may find grass debris. You may find seeds, individual pieces of dirt. It's a mixture. A salad, again, it's a very common one. Kool-Aid is a mixture. If you boil out the water, you'll be left over with the powder that makes up that delicious beverage. Salt water is also a mixture. Okay, our next question is asking us to define compounds. And this is where we're getting into kind of our new stuff. Okay, a compound is a substance formed of two or more atoms or elements. Okay, the elements lose their individual chemical properties and the compound has a new property. So if we look at this picture here, everybody knows the formula H2O. Okay, we're going to take two atoms or two elements of hydrogen and combine them with one of oxygen. Once they're all bonded together, they make water. Okay, so they lose their individual identity. It's kind of like when people get in a relationship with one another, they become known as like those celebrity couples like Brangelina, you know, they're not together anymore, or Will Smith and Jada Pinkett, you know, they're couples that people just associate with each other. They've lost their individual identity and become something together. Here's some other examples of some compounds. This picture is just a little bit blurry, but we're going to make it work. Okay, of course we have up here at the top left, you have water. Okay, you got two atoms of hydrogen here and then one of oxygen, like I just explained. Then you have carbon dioxide, which is a gas. That's one carbon with two oxygen. Okay, ammonia is a cleaning agent that smells absolutely horrible. Never mix ammonia with bleach if you didn't know that. It creates a deadly gas and you could die. Okay, but it involves one atom of nitrogen and three hydrogen. And then methane, which is also a gas, it's four different hydrogens with carbon. Okay, next question. What's a molecule? It's a compound of two or more atoms. It's the smallest unit of all chemical compounds. Okay, so to this picture, or looking at this picture, excuse me, right here, this is one molecule of water. If I were to try to get a little creative, I could take two more yellow, okay, that's going to represent the H here. And then I can add one more red, which represents the O. I now have two molecules. So this is one molecule of H2O, and the really kindergarten looking one that I just drew will make it two molecules. Okay, now we have what are formulas? They're numbers and types of atoms in a molecule. The formula which identifies the atoms and the number of each kind in the molecules of a compound. So this is glucose. It's a type of sugar. Now, this one's not written 100% well. These big numbers here actually should be a little bit smaller, but I mean, can't trust everything you find on the internet. It should look like this. Capital C with a small 6, capital H with a small 12, capital O with a small 6. That's really what it should look like, but this is a chemical formula. Another one is capital Na, with a capital C and a lowercase l. A lot of y'all think this is an I, and I can't get the draw on the screen. There it is. All right, that's another chemical formula. Another one that we have referred to several times in this presentation. You all know it, H2O, which is water. So you have many, many different types of formulas. All right, now I'm throwing a lot of words at you, but we have to differentiate between subscripts and coefficients. Remember, to differentiate means to tell the difference between. So a subscript is essentially a small number to show the number of atoms of an element, okay? So we're talking about all these tiny, tiny numbers here. Remember in the previous slide, I just showed you that glucose that they drew, the number's too big. Okay, so subscript is a small number. You may have heard of subscripts in math. Okay, it's a small number that tells the number of atoms of each element. So make sure you write this whole thing down in that blank. Yes, I know it's small. Let's just make it work. Okay, guys? What the subscript is basically telling us is how many of each of those elements that we have in our molecules or in our compounds. Okay, so in CO2, which is carbon dioxide, I have one carbon. Okay, And because I see the capital C there, I know I have at least one. So you'll never see a 1 subscript, but I'm going to challenge you guys to every time you see 1 by itself, that you are going to go ahead and add that 1 there. So I have 1 atom of carbon, I have 2 of oxygen. Okay, here's another formula, CH4. You have 1 carbon and you have 4 hydrogen. And then there's that glucose formula again, written the correct way this time. It is 6 carbon, 12 hydrogen, and 6 oxygen. Lastly, we have coefficients. These are large numbers that tell the number of molecules in a chemical formula. So if you remember, I drew 2 molecules of hydrogen. So give me just a second here. And like magic, there it is. I have 2 molecules of water here. The little bitty orange ones here are going to represent my hydrogen, or yellow, whatever color y'all think that is. And then these are my oxygens. So notice how I did not draw them together per se, but they still maintain each that they are both H2O. So that one's H2O, and so is this one. And instead of me writing H2O twice, I'm going to simplify it. Excuse me while I erase very slowly. I'm going to simplify it. So if you saw this, you would write down that it's 2 H2O. I have 2 sets of water. And I boxed in that formula. That's a practice that we're going to do when we actually start counting formulas together. Okay, so look at this. This is a formula. This is a badly written formula. I don't like this because it's not right. We have to make sure that our coefficients are big and our subscripts are small. So I'm going to correct this for us. It should be 6 with a capital C. Your coefficients are always going to be in front of the formula, and they will always be the same size as the elements or the chemical symbols of your formula. Then you should have 6 with a capital H, a subscript of 12, a capital O, and a subscript of 6. That is how that is supposed to look. So we want to identify the elements in this compound. Well, right there is the answer. But how do you know this? You're looking for the chemical symbol. Capital C, the capital H, and the capital O. I have 3 elements in that formula. Okay, now we're looking at just the subscripts in here. So kind of for a second, ignore this coefficient. And we want to know the number of atoms of each element in the molecule. So I look at the subscript, okay? The subscript is always to the right of the chemical symbol that you're talking about. So this 6 goes with this C. Think of it as a mother. The C is the mom. The subscript is the kid, okay? Carbon, mom carbon, has 6 kids, or she has 6 atoms, okay? So hydrogen has 12, and then oxygen has 6. Really, really simple. Then lastly, we have our coefficients. That is our big number here. Remember, that tells us how many molecules we have, okay? Or how many sets of glucose, okay? So I'm not going to draw this perfectly because it'd be really hard for me to draw this fast. But if each of these black circles was a molecule of carbon, I have 6 sets of it. I'm sorry, of glucose. So these are all glucose. I'm going to draw a really ugly G inside of it. It's really hard to draw on an iPad if you guys did not know that. Okay, so I have 6 molecules of glucose. So guys, that's pretty much it. I mean, I know it almost took me 15 minutes to go through this, but I hope that you were able to get this information and filled in all of your blanks. You have a little bit of time to rewind before we go over the activity as a class.